Picture a reality where every decision you make spawns a new universe. Welcome to the many worlds interpretation of quantum mechanics. This fascinating theory arises from the complex and often counterintuitive world of quantum mechanics, a field of physics that delves into the behavior of particles at the tiniest scales. At the heart of quantum mechanics lies the principle of superposition. To simplify, imagine a particle that can exist in multiple states simultaneously until observed or measured. This paradoxical concept is like having a coin suspended mid-air, being both heads and tails until it lands. Now, extend this idea to the universe. The many worlds interpretation suggests that for every possible outcome of a quantum event, the world splits into different realities. Each version of reality exists in its own separate universe with its own unique timeline. Quantum mechanics, a realm where reality is not as it seems, and where multiple universes could be just a quantum event away. The many worlds interpretation, or MWI, didn't just materialize out of thin air. It has its roots in the groundbreaking work of physicist Hugh Everett III. Back in the mid-20th century, Everett, a young, audacious physicist, proposed a radical idea that would challenge the traditional interpretations of quantum mechanics. His relative state formulation, later known as the many worlds interpretation, was born out of his doctoral thesis in 1957. Everett's theory was seen as a heretical departure from the conventional Copenhagen interpretation, which dominated the quantum mechanics scene at that time. The Copenhagen interpretation suggested that the act of measuring a quantum system would cause its superposition to collapse into a single state. But Everett had a different take. He proposed that instead of collapsing into one state, all possible outcomes of the quantum superposition continue to exist in a separate, non-communicating universe. His relative state formulation essentially suggested that every possible outcome of a quantum event exists in its own separate universe, birthing the concept of parallel universes. To say that Everett's ideas were met with skepticism would be an understatement. His peers found his views hard to swallow. Many dismissed his ideas as pure science fiction, yet despite the initial resistance, Everett's ideas persisted, slowly gaining traction among a new generation of physicists. As time passed, the many worlds interpretation began to gain ground. Its mathematical elegance and its ability to explain certain quantum phenomena without resorting to the paradoxes of the Copenhagen interpretation made it increasingly appealing. Today, while not universally accepted, the many worlds interpretation is considered one of the leading interpretations of quantum mechanics. Everett's bold ideas set the stage for a radical rethinking of reality, one that includes the existence of countless parallel universes. His pioneering work ignited a scientific and philosophical revolution that continues to challenge our understanding of the universe and our place in it. But how exactly does a new universe come into being? The answer lies in the quantum event. To understand this, we need to delve into the realm of quantum mechanics, where particles don't have definite states until they're measured. This is known as superposition. A particle can be in multiple states at the same time, like Schrödinger's cat, being both alive and dead. But when we observe or measure the state of the particle, it collapses into one of the possible states. This is where the many worlds interpretation comes into play. According to this theory, instead of the particle collapsing into one state, all possible states of the particle continue to exist, but in separate parallel universes. So in one universe, the cat is alive, and in another, the cat is dead. Imagine a tree with numerous branches. Each branch represents a possible outcome or state. When a quantum event occurs, it's like the tree sprouting a new branch. This process of branching is continuous and unending, leading to an infinite number of universes, each representing a different possible outcome of reality. But these universes don't communicate with each other. Once a universe branches off, it evolves independently with no knowledge of the other universes. It's like each universe is encased in its own bubble of reality, oblivious to the countless other bubbles floating in the cosmic sea. It's important to note that these parallel universes aren't physical spaces that we can travel to. They exist in the abstract mathematical realm of quantum mechanics. So while we can't pack our bags and set off to explore these parallel realities, we can certainly marvel at the sheer wonder and complexity of the quantum world. The many worlds interpretation provides a fascinating perspective on the nature of reality. It suggests that every possible outcome of every event, no matter how trivial, exists in some universe. It's a mind-boggling thought, isn't it? Every quantum event, every choice you make, could be creating a new parallel universe. The many worlds interpretation isn't just a scientific theory, it has profound philosophical implications that challenge our understanding of reality. As we delve further into the many worlds interpretation, we can't ignore its philosophical aspects. These theories not only reshape our understanding of the physical world, but also force us to reconsider some of our most fundamental beliefs. Let's start with the concept of free will. If every possible outcome of every event defines a new world, then is our sense of choice an illusion? Are we merely one thread in an infinite tapestry of realities? Are decisions merely the path we're destined to follow in this particular universe? And what about determinism? The traditional view of a universe following strict physical laws is disrupted by MWI. Instead, we're presented with a quantum multiverse where everything that can happen does happen. This raises intriguing questions about causality and the nature of existence. However, the most profound philosophical implication of MWI might be its impact on our understanding of reality itself. If countless parallel universes exist, each as real as our own, what does it mean to be real? How do we define our existence if there are infinite versions of us living out entirely different lives in parallel realities? The role of observation, too, takes on a new dimension in this context. In classical physics, we're mere spectators in the theater of the universe. But MWI suggests that our observations might actually be shaping the reality we experience. Every measurement, every observation, might be creating a new branch in the quantum multiverse. As you can see, the many worlds interpretation is more than a scientific concept. It's a philosophical rabbit hole, challenging our deepest beliefs about the universe and our place in it. It invites us to question, to wonder, to rethink our understanding of reality. So next time you're faced with a decision, remember, somewhere in the vast quantum multiverse, there's a version of you who made a different choice.